Hello everybody, Dusty from Discovery Lab in Tulsa, Oklahoma here for Discover at Home, a series of activities that you can perform at home with a parent or caregiver. Our experiment for today is building an anemometer, where we're going to be learning about earth sciences as well as averages. Now some of you guys may be wondering, what's an anemometer? An anemometer is a device that we use to measure wind speed. So if we want to know exactly how fast the wind is blowing, we use an anemometer to discover that. Now, wind is something we have a lot here in Oklahoma, and you may be wondering, what makes wind happen? Well, wind happens when we have two different areas of high and low pressure air. Whenever they meet, they want to go under and over each other. This exchange of air causes wind to flow and blow. This can be caused by a lot of different things. For instance, we could have cold air coming from the north, like the North Pole, which comes down and then runs into a mass of air from the Gulf of Mexico, which is very hot and very wet. Whenever they run into each other, they want to shift places and change where they are. That causes the wind to sweep down. Sometimes we want to know exactly what's going to happen to that wind. It can cause storms sometimes, like tornadoes. So that's why meteorologists and scientists really want to study the way that wind moves. We can also capture wind for energy. Whenever you guys are driving on the road, you've probably seen a lot of giant wind turbines. That lets us take the energy from the wind and be able to convert it to electrical energy to power our homes. If you'd like to make an anemometer with us, here's some supplies you'll need to do so. You're going to need some small paper cups. If you don't have small paper cups and instead you have larger plastic cups, that's okay. You'll just want to cut them down so that they're smaller. You don't want these big guys. You want something a bit closer to a smaller paper cup like so. You'll also need some tape. 4 straws. Now, if you don't have straws, you could substitute with long popsicle sticks. Just know that it's going to be a little bit different and possibly a little bit more difficult if you're using any other thing than straws. You're also going to need a pencil, one that has a very good eraser. This one is brand new and it's never been used. You'll need a marking instrument. I'm going to use a permanent marker. You could easily use any other type of marker or paint. You're going to need a hole punch, a push pin or thumbtack, and a nail. To record your findings, you're also going to want paper and pencil. To be even more scientific, you'll want a stopwatch, or you can use an app on your phone. If you'd like to extend some activities, we're going to give you some ideas to do that as well. And for those, you want a calculator, and again, you can use an app on your phone, or a ruler, or measuring tape. All right, let's get started building our anemometer. You're first going to grab your cups. You're going to take your hole punch and you're going to punch 2 holes on opposite sides of the cups in a straight line. So I'm going to grab my hole punch and punch 1, turn it all the way to the other side, and 2. Now you can see my cup has 1, 2 holes on opposite sides. Do that to all 4 cups until you've got 4 cups with holes punched on opposite sides. Next, you're going to take your straws. If you're using popsicle sticks or some other material, you'd want to use glue or tape or something to join them, but I'm going to join my straws in a slightly different way. I want to make them very, very long. So to do that, I'm going to stick them together by pinching the side of one and then sticking it in the other one, like so, and I get a really long straw. Do that to both sides. Now, you want them to be pretty even, as close as you can, and looks like I got those pretty good. Like I said, if you're using sticks or something like that, use hot glue, you can use tape, but try and get them fairly long. You want them to be pretty long. Next, you're going to align your straws in an X shape. So in other words, it needs to be perpendicular. If you look at my angles right here, they're square corners, 90-degree angles on all 4 sides. Try and get them as straight as possible. If it's off a little bit, straighten it back up. Grab some tape and tape it right in the middle. Wrapping it around a few times to make sure it's nice and snug. You don't want it to wiggle or move if you can help it. Let's see. I think that looks pretty secure, but feel free to use a little bit more tape if you need to. The next thing I'm going to do is I'm going to poke a hole in the middle of my X. So I'm going to take my nail, and I'm going to push down right in the middle. You want to get through both of them, and if you need to give it a little twist, a little push, that's okay. You're wanting to make a hole that is bigger than your push pin. Let's see, can I get my push pin through there? Oh, it's a little tight, so I'm going to make it a little bit bigger. Your push pin should be able to spin freely. You guys may be wondering, why are we calling this an anemometer? Well, you might have heard of a thermometer. That measures how hot something is. The word thermo means heat. We're measuring wind. So we've got an anemometer. That first part, ana, means wind. It's from a Greek word, anemos. All right, I think I've got that guy. Ah, there we go. Pretty well pierced. Whew, that was a little harder than I thought it was going to be. But now, yeah, that's going to spin nicely. All right, it's time to attach our cups to our X. Slide them through on each side. Now, you can see they kind of wiggle a lot. I don't want them to be solid, but I definitely want them to not fly off whenever it's spinning. To do that, I'm going to grab a little bit of tape. What I'm going to do is I'm going to tape the cup where it doesn't fall off. Tape it to the straw. You can tape it on both sides, you can tape it on one side. I'm going to tape mine on both sides just to make certain that it doesn't fall off. See how I'm placing it in that direction right there? That's the way you want it, because the way we're going to hold it is the wind is going to hit it this way. Go ahead and tape all 4 cups on. Keep them where they're facing the same way. You see how my cups are all facing the same way, kind of like a windmill. If you guys have ever seen those big giant turbines on the side of the road that make electricity, you might have called them windmills. That's a common misconception. Those are called wind turbines. A windmill is something you might see out in the middle of a field. A windmill actually pumps water up from the ground. It uses the power of wind just like a wind turbine, but it doesn't produce electricity like a wind turbine would. Here in Oklahoma, we have a lot of wind, don't we? That's okay. And one more. All right. Now, you may be wondering, why would we want to measure the wind? Well, like we said earlier, sometimes we might be worried about wind causing damage. But we also want to know what wind speeds are during certain times of the year or in certain places. That's what we call climate. For instance, we know that certain times of the year will be hotter and windier, certain times will be colder and wetter, and we want to study that and see if there's any changes, to see if our climate has changed any. Is it windier than it normally is? Is it less windy? Is it hotter? That's why we test things like this. All right, I've got my cups attached to my straws like so. Now it's time to attach it to my pencil. Take your push pin, push it through the hole, and then onto your rubber eraser. Make sure it's not too tight. You don't want it to be stuck. You want it to spin pretty freely, just like a windmill. Now, it's time for the last step. I need to mark one of these guys. I'm going to pick one that I like a lot. I think this one right here. I'm going to put a big X on it, and then color it in. I want a spot that I can see whenever we're going outside to measure our wind. I need to know the difference between this cup and the other cups. And don't worry if yours comes off like mine did. Stick it right back on there. All right. I think it's time for us to go outside and test our anemometer. All right. It's time to test our anemometer. So what we're going to do is we're going to see if we can measure how fast the wind is blowing by counting the number of rotations or spins that my anemometer makes. That's why it's important that all my cups are facing the same way, so that way they catch the wind and the wind will push them around. I also want to make certain that my push pin is pushed in firmly so my anemometer doesn't spin off. You're also going to need a pencil and a piece of paper to record your findings. You'll also want a timer or a stopwatch to make certain you keep accurate time. So what we're going to do is we're going to start our timer for 30 seconds. Then I'm going to watch this guy. Every time I see this little black dot, I'm going to count. And I'm going to see how many times it comes around in 30 seconds. All right, let's see. Got it ready. And go. So here's one of the fun things about experimentation in engineering. Sometimes you find that a part isn't working well and you have to find a substitute that's going to work even better. So my push pin was having trouble staying in. So what I've done is I've substituted my push pin for a paper clip. My paper clip is longer and it goes into my eraser just as easily. And now my anemometer isn't going to fall apart. So I can begin to do my experiment all over again. So I'm going to try one more time to measure for 30 seconds how many times I see this little black dot and then write it down. All right, so let's go. All right, so my anemometer made a total of 4 spins or revolutions that I counted. My black dot came around 4 different times. Now, what I'm going to do is I'm going to try and find the average of the wind in this area. I'm going to move to a different spot and I'm going to measure my wind again. But first, I need to record my original findings. Let's go find a different area to measure. All right, let's measure again for another 30 seconds. All right, so I got 15 revolutions that time, way different than the 4 I got earlier. So I need to record that data. All right, let's go find a different spot so that way we get a really good average. All right, we're in a different location now so that way we can measure the wind in this area. And here we go. All right, we got 12 rotations that time. So I'm going to take note of that. All right, let's go inside and find the average wind speed that we measured today. Let's find the average of those speeds that we found. So to do that, I'm going to write down the 3 speeds: 4, 15, and 12. Remember, that was the number of spins or revolutions I counted in 30 seconds. I'm going to add those 3 numbers together. So together, those numbers add up to 31. To find the average, I then divide this sum by the number of numbers that I added together. Since I added 3 numbers, 4, 15, and 12 together, I need to divide this one by 3. So 31 divided by 3. I end up with 10.3 repeating. one number, we'd get a very different idea of the wind for the day. If I just used the 4, I would think there was almost no wind today. If I used the 15, I would think it was very windy. So it would give me a skewed view of the wind. That's why we don't just use a single point. We average out several different points. We measure them at different places, different times of the day, even different times of the year. That's how we determine the average wind speed or the climate for a particular time and a particular place. We've measured our wind speed in 3 different areas, then found the average of those 3. There are some other things you guys could do with our already made anemometer if you'd like to extend this activity. You could take several different measurements at several times during the day, then graph them on a bar graph or a line graph to determine which day is the windiest, which time of the day is the windiest. You could also find out the average for each day and the average for each week. If you'd like an extra hard challenge, you could also try and figure out what the number of revolutions equal in miles per hour. To do that, you'll need a couple of different formulas, which we'll link below. Hopefully you all have enjoyed building an anemometer with me and learned a little bit about wind speed. Thanks so much for hanging out with us here at Discovery Lab.